Hello, everybody. We are back with another visual pattern challenge. Here is step 1 in our pattern. Here is step 2, and here is step 3. Your challenge would be to predict how many of these blocks in step 4. And if you can do that, how many in step 43? And can you write an equation to express the number of blocks in any step at all? That's the challenge. If you'd like to accept it, pause the video and work it out. All right, so we've got some interesting sort of, I don't know, castle shapes going on here. Um, Here we've got, let's see, the bottom part, and then we've got this sort of top part. There's 2 on the bottom, and there's 5 that make up this top part. And then it looks like we widen the bottom and we add a prong here. And then we widen the bottom and we add another prong here. Let's see, the bottom here is 1 wide and then 3 wide and then 5 wide. So I'm going to guess the bottom here is going to be 7 wide and 2 tall. That's what I think. And then there should be, well, there's 1, 2, 3, 4 prongs, right? So there should be 5 more. And the way we've been doing that, or they've been doing that, is just adding this shape here, right? So it should come like this. So that would be 3 more for adding the prong, I think. So it's plus 3 for the prong, something like that. So 2 times 7 would be 14. Oh, and then we've got to get all the other prongs, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 plus 3 would be 14. So 14 and 14. It looks like they're going to be 28 in that next step. So that's my prediction. So just glancing at this, I'm not sure. Is this a linear pattern? Is it something else? I don't know. So what I'm going to do is analyze these numbers. I think we've got the right prediction for step 4, but I want to analyze the numbers, and this will confirm our guess as well. So we've got the step number, and then we'll take the number of blocks or squares here. And in step 1, there are 7 blocks. And in step 2, we've got this portion of 6, and then 5 more is 11, 12, 13, 14. So in 2, there's 14. Wow, it looks like it doubled off the bat. And then in step 3, we've got this 2 times 5 part. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 21. Oh, I think I see what's happening. And in step 4, we're predicting 28. Do you see anything special about these numbers of blocks? What I'm noticing is that they are all multiples of 7. Isn't that interesting? And if we take the differences, which is usually what we do to analyze numbers in a pattern, 14 minus 7 is 7, 21 minus 14 is 7, and 28 minus 21 is also 7. And when you get the same number in this first set of differences, you know it's a linear pattern. And we can use this equation y equals mx plus b to model that. And the m, the slope in the line, is the rate of change between each step. So y equals 7x. And then sometimes there's a plus b when we need it to make it adjust to the pattern that's up there. But I don't think we need it, because 7 times 1 would be 7, right? So if we applied this formula, y equals 7 times the step number, x is the step number, 7 times 1 would be 7. That's how many there are. Here would be y equals 7 times step 2. That's how many there are. There are 14 blocks there. So I think our equation is as simple as that. So that's pretty nice. And from there, it's pretty easy to figure out how many in step 43. We just plug step 43 in for x. Okay, 7 times 43. Let me see if I can do this in my head. 7 times 40 would be 280. And 7 times 3 would be 21. So that would be 301 blocks in step number 43. Well, how did that go for you? Did you see that it was a linear pattern? Did you get 28 for step number 4? Let me know. Thanks, everybody.